Welcome to PreMath. In this video, we have got these two line segments BE and BF inside this square ABCD, as you can see in this diagram, such that this line segment DE is equal to this line segment EC. And furthermore, if this line segment AF is Y, then this line segment FD is going to be 2y. And now we are going to calculate this angle X. Please don't forget to give a thumbs up and subscribe. Let me make it very clear that this figure may not be 100% true to the scale. Let's go ahead and get started with the solution. And here's our very first step. Let's focus on this side length of this square. This is y and 2y. If we add them, this side length is going to be 3 times y. And since we are dealing with this square ABCD, that means this side length is equal to this side length equals to this side length equal to this side length across the board. So if this side length is 3y, then this side length has got to be 3y, 3y, and 3y as well. And now we know that this E is a midpoint. So therefore this line segment DE is going to be 3y divided by 2. Likewise, this line segment EC is going to be 3y divided by 2 as well. And here's our next step. Let me go ahead and label this angle as alpha and this angle as beta. And now our task is to find the value of alpha plus beta angle. And we know that this whole angle is 90 degrees. If we figure out this alpha plus beta angle, we can easily figure out our angle X. So therefore, in such kind of mathematical problem, we are going to use not only geometry, but trigonometry as well. And these are very powerful tools in mathematics. And here's our next step. Let's focus on this right triangle FAB. And now let's recall SOHCAHTOA, and we are interested in tangent of theta equals to opposite over adjacent. And here in our case, our opposite side is y and our adjacent side is 3 times y. So therefore, tangent of this angle alpha is going to be, I can write down tangent of alpha equals to opposite our case is y divided by adjacent is 3 times y. And here we can see y and y cancels out. So therefore, tangent of alpha turns out to be 1 divided by 3. And here's our next step. Let's focus on this another right triangle ECB. And once again, we are going to use this SOHCAHTOA model. Once again, we are interested in tangent of theta equals to opposite divided by adjacent. And in our case, our opposite side is this one, 3y divided by 2. And our adjacent side is 3 times y. So therefore, our tangent of angle beta is going to be opposite in our case is 3y divided by 2 all over 3 times y. And now we can see on this numerator 3y divided by 2, we could tweak it. We can write it like 1 divided by 2 times 3y. And now we can see this 3y and 3y is gone. So we ended up with simply 1 divided by 2. So therefore, our tangent beta turns out to be equal to 1 divided by 2. And now let's recall this famous trigonometric identity. Tangent of alpha plus beta could be written as tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. And now in our case, our tangent of alpha is 1 divided by 3 and tangent of beta is 1 divided by 2. So therefore, this way we can figure out our alpha plus beta angle. So let's go ahead and fill in the blanks in this formula. Tangent of alpha plus beta is going to be equal to, in our case, tangent of alpha is 1 divided by 3 plus tangent of beta is 1 divided by 2 all over 1 minus tangent of alpha is 1 divided by 3 times tangent of beta is 1 divided by 2. And now let's focus on this numerator part. And here I have copied it down, and let me show you how to add these two fractions. Simply we're gonna cross 1 times 2 is going to give us 2, and then whatever sign this one plus the other way around, 1 times 3 is 3 divided by, we are going to multiply out these denominators. 2 times 3 is going to give us 6. So therefore this whole thing turns out to be 5 divided by 6. So therefore I'm going to replace this whole thing by 5 divided by 6. So therefore the numerator part becomes 5 divided by 6 divided by 1 minus, now 1 divided by 3 times 1 divided by 2 is going to give us 1 divided by 6. So therefore I'm going to replace this one by 1 divided by 6. And now let's focus on this denominator part. And here I have copied it down. And here I replace 1 by 6 divided by 6. And then if we simplify everything, this turns out to be 5 divided by 6. So therefore I'm going to replace this whole denominator by 5 divided by 6. And now this is going to give us simply 1. So therefore our tangent of alpha plus beta turns out to be equal to 1. Alpha plus beta is equal to tangent inverse of 1. And we know the value of tangent inverse of 1 is 45 degrees. So therefore this angle alpha plus beta turns out to be equal to 45 degrees. And here's our final step. Let's make an observation. We can see that the sum of all these three angles, alpha plus beta and this angle x, this adds up to 90 degrees, as you can see in this equation. But we know our angle alpha plus beta is 45 degrees. As you can see in this next step, I have replaced this alpha plus beta by 45 degrees. Now let's go ahead and subtract 45 degrees from both sides. This is gone. So therefore our angle x turns out to be 90 degrees minus 45 degrees is going to give us 45 degrees. So thus our angle x turns out to be 45 degrees. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.